Carl Schultz, President of Packline Corporation and Packline Conveyors Inc. We're in Packline's demonstration lab, and today I'm going to give you a quick lesson on overhead conveying basics. As you can see behind me, I have an overhead conveyor. This is our model C250 synchronous overhead conveyor. It's an enclosed track variety. By synchronous, we mean that all the loads on this conveyor travel at exactly the same pace. If we stop the conveyor, they all stop together. If we start the conveyor, they start again. By enclosed track, we mean that the chain that's inside of this track is almost completely invisible to you. This makes it very safe, so you can put your hand right on the side without being pinched or injured. And if I was to be doing a spray painting operation, the overspray isn't going to get to the chain, which is very important because if you contaminate your chain, it reduces its life. The basics of an overhead conveyor are that you have an endless chain running through this track. The circuit itself is made up of a variety of different curves and straight track. To propel the chain, we need to have a drive unit. This is the drive unit of this particular unit. It has a capacity of 600 pounds of pull. It consists of a caterpillar chain arrangement, which has drive dogs on. And these will actually grab the chain. This is a section of chain that's in this track. You can see it has vertical and horizontal bearings and linkages. That allows it to be flexible, to go up and down around corners. This is the track itself. It's almost completely enclosed except for a slot here. This chain runs inside this track, and the only exposed part is what we call a chain pendant. That's where you hang your loads. So, to pull this chain through this track, the drive unit will grab this horizontal bearing. So those drive dogs that are on that caterpillar chain will come down around that horizontal bearing and pull it forward. As I said, that drive is capable of pulling 600 pounds of force. Now, that usually means that a simple conveyor system like this, maybe carrying with light loads, would be able to pull up to 800 feet of chain and product beneath it. And it can do it with a fractional horsepower motor. Quite often, drive units have variable speed controllers on them. So the motor that's on that drive will have a variable speed controller that will allow us to turn the speed up or down to fine-tune for certain operations. For example, in a spray painting operation, if you had a complicated part like this and I was spraying it, I would want to be going at a fairly slow speed so I could get all the areas. For simpler parts, I might want it to go faster. With the turn of a dial, I can make sure that I get exactly the speed that I want. Typically, a hairdryer you have at home will consume more power than this conveyor will when it's fully loaded, pulling 800 feet. So it's very energy efficient. Another important component of this conveyor system is the take-up unit that follows the drive. There's a take-up unit. I have a sample on the table here. Show you the components. So basically, the take-up unit consists of a 180-degree curve and two telescopic sections of track. Over the years, the chain will wear slightly and get longer and longer, and you need to be able to take this up. Remember, we have a fixed track circuit, and if there's nowhere for that stretched chain, that extra length of chain to go, it's going to bunch up in the track and cause a jam. So this 180-degree curve will be pushed out actually by these two springs, thereby taking up the slack chain that's being produced over the years of running. You can also have pneumatic take-ups in place of this spring, or you can use counterbalance weights. On this conveyor right now, we have a variety of different loads. The loads are attached to the conveyor by a carrier. So these carriers have to be designed so they can go up and down inclines and declines. The carriers can be designed so that the loads rotate automatically. For example, if I'm spraying this very complex part, I would want it rotating in front of me, traveling at the right speed so that I can get all the corners of it. You can make loads indexed 90 degrees each time. You can even make very complex carriers that tilt the load or rotate it in some way for operator interaction. Every system has to be supported in some way. In this case, we have floor supports. You can see these structural steel supports. They would be bolted to the floor, and they have arms or header steel going across the top, from which we would suspend the conveyor. We at Packline try to make our products as versatile and easy to use as possible. So we manufacture a variety of different components for you to attach either to the ceiling of a building or to the floor. So typical ceiling installations would involve open web steel joists or beams or wooden beams or concrete, and we have a variety of attachments to help you attach it to any one of those particular ceiling styles. In general, our whole philosophy at Packline is to make our conveyors easy to install, but that help you get your products up off the floor. Floor space is so valuable. In most factories and warehouses, the overhead space is unused, yet you have to heat it and light it and so forth. So we promote getting products up off the floor and into that space and freeing up the valuable floor space for other operations where people are actually working. I hope I've given you enough of the basics for you to understand how the conveyor system works. If you need any help designing your system, by all means give us a call. One of our engineers will be able to assist you at any time. Thank you.